But when we have a lot of red X's on CI, everybody just thinks red X's on CI are acceptable. So we got to fix this.
Is this the same like GPU falling off the bus issue? Because last time I mentioned this,
This looks more like an HTQ2 issue. MLPerf AMD. And then how many of our runners are up right now? Alerts for this. What was Parrot?
Yeah,
Yeah, we have 2 of our AMD CI runners down right now. It's really important that we get CI to be stable. It just lowers development velocity for everybody else when it's not. Yeah, I've been working on the Gitya thing. I split the unit tests into platform tests. Platform tests are stuff that needs like Windows or Mac. Unit tests can run Linux. So yeah, no, I want to get our CI to be under 1 minute and never fail, and that's including benchmark. We can't have CI. Launching the chestnut this week. Who's ever working? I don't know if the person working on the NVIDIA stuff is in here, but I will send you a free chestnut if you'd like. The chestnuts are unbrickable, which is cool. Yeah, so there's that. Yeah, and that'll fix your bricking issue. It looks like we can support NVIDIA over USB 3, even though it might be a little slow. To boot. So yeah, with that, let's start with the first meeting item. Why is Slice still here?
Yeah, I don't know. So I can remove it. And I think this is what I'm gonna do today, is just remove it without trying to do the variable offset thing. I was just running into a lot of issues with this where I would get all the tests to pass and then I would push to benchmarks and then a whole bunch of stuff would be failing and then I would change something and then it just felt like it was just doing that over and over again where there's like some small things. So like the most recent thing was that like Beam. So when it runs this, it needs to allocate the buffers to test the kernels on, and then would allocate the whole 24
Yeah, I
kilobyte
understand.
buffer. Yeah.
Okay, maybe you can do it the other way. Yeah, let's just get that merged. Let's get Slice deleted. Every UOP we delete. Every time we can make the spec a tiny bit cleaner. You're reducing something that is n squared in complexity, right? Because every op, so our op size is n squared complexity, because every op can sit on top of every other op. You always have to think for every op, what's its interaction with every other op, and that's n squared. So every time we can lower the number of ops, we're lowering something that's n squared.
Yeah. No, in retrospect, I should have just done this from the first place because I actually had code that was mergeable that would remove slice that would that didn't have the variable thing. I should have just done that.
Great. Well, we can document the variable thing and think about that later.
Yeah.
Yeah, and then I want you back on CI.
Yeah.
Yeah. So for the GitHub Gitya CI, Gitya has 2 images. It has like a base image and then it has a full image. So the full images work. But what we should just do is we should have a Docker file. What was the downside to just having one Docker that doesn't have to pre-install anything?
It was really slow to clone even on the namespace runners, but I think if we do it on our own stuff, then we can probably just like have it set up already. And then,
Yeah, I think that the right way to do this is just, I don't know. I don't want to deal with namespace or GitHub Actions. I mean, this still has to work on GitHub Actions, but I think we can get rid of namespace entirely, and just move our runners to here, and we can have them only work on Gitya, and we can move GitHub back to just GitHub Actions. So it needs to run on GitHub with GitHub Actions.
Yeah.
But everybody internally here can move to Gitya. And then, yeah, we'll see what to do about benchmark. Right now, you'll have to use GitHub if you want to push to benchmark. If you're just doing stuff that's like the unit test CI, that should be very fast on Gitea.
Yeah.
And we need to figure out how to.
Yeah, and I bet there's some way we can set this up like intermittently to like be like, oh, we can. I don't know. I'm just interested about how we're gonna do pull requests on both sites, or if we're just gonna move everything. Or...
Yeah, I don't know about that. We'll see. But the first step is just getting CI to be under a minute.
Yeah.
With Docker and all of this CI flakiness. We need to really be on top of this.
Yeah.
Frustrating for everybody.
Yeah.
Okay. Anything else?
No, not really.
Cool. So Slice going today?
Yeah.
Great. Okay. Why is Llama not faster?
Llama is faster. I'll share the chart. This is comparing with last sprint.
All right.
For some reason, I have converged runs in one eval step more. So I think this is seed thing. Maybe if we find a better seed, can converge in the same number of steps.
I don't think we should be messing with seed. But
Yeah.
right, yeah. So how is it? It's almost 10% faster, yet the runtime only reduced 2 minutes.
Because it took more steps to converge.
More steps to converge. Is this an FP4 thing?
This is compared with FP4. It converged in the same number of steps as AMD. So
Cool.
even AMD converged in this number of steps.
And then what's the latest for where we're still spending time?
Yes, I'll share that too. We are 76 milliseconds off, 79 milliseconds off from AMD.
Oh, so by the way, why it might
Yeah.
be slower today, it's possible that it's hotter today.
Oh yeah, the machine got slower. Yeah, I noticed
Yeah,
that.
I mean, that's one possibility. Another possibility is there's cruft on the machine that needs to be rebooted. Another possibility is there's yeah. Okay, so plus means that's why we're slower.
Yes. Plus means we are slower than AMD.
Oh, but okay, so there's no more scheduler issues.
No more scheduler issues. Well,
We don't have to
idle
deal with
time.
this. Like the SDMA thing is fine.
SDMA thing is not fine because we're spending more time with idle. So our idle time is worse than AMD. See,
Yeah, but
we're
it's
losing.
on that thing you just posted. It says idle is 0 milliseconds.
Oh, idle, this here means like SDMA and compute combined. So like whenever compute is not busy, but SDMA is busy, waiting for the compute. The main thing is that we have a less exposed time. We have more exposed times. So we have more time where we're just sitting and not doing anything.
See, well, that's
If
not yeah, that's not reflected in this.
Yes, this is focused on the kernels. If I copy their flash attention and I copy their gem and I copy their optimizer, they have another optimizer thing. They don't do it like they have something similar to our zero optem, which isn't default for us.
What do you mean by 0? You mean fuse optim?
Yeah, the distributed one.
Oh, they're doing some distributed stuff.
Yes.
Okay. I mean, so looking at this, just going down and sorting, the top two things seem to be flash attention and element-wise reductions.
Mm-hmm.
Yeah, but so like, how important is it that I thought most of what this was going to be about was the SDMA stuff.
So I fixed some stuff and idle time went down. So SDMA became less of a problem.
If it's something we don't have to deal with, I'm very happy to not deal with that. Yeah, no, I mean, especially until HTQ2 is a bit more stable. Like we definitely have a path to doing it, but yeah, it makes sense what they're doing. So my understanding from what you posted is that there's two compute queues. On one of the compute queues, you have a small global size copy that's higher priority. And that's just scheduling on CUs. It looks like it's something like 4 CUs is capable of copying. Yeah, I mean, that's going to be some hit to performance, but only like 2% or something. Like, there's a question of how many CUs can saturate the PCIe bandwidth. And if that's small enough, then yeah, just using CUs and not using the SDMA engine seems kind of nice because then we could do fancier collectives. We could do collectives that actually like do the math right away and don't have to round trip that to global memory, right? Because the SDMA engine is only capable of writing to global memory. So you have to like write to global memory, wait for it to finish, then you can do like the actual reduce. Versus if you can just read from another thing, then yeah, you can definitely get there. But if you think we can beat AMD's time just by, I mean, these things all stack. So yeah, if we could just improve flash attention, element wise, EF16 gems. We're using hip kittens now for flash attention.
We are using hip kittens.
What's AMD using?
AMD is using Acher, which is like Ryzen.
Can we make it just easy to call ADER kernels?
Yes, it's gonna be the thing that I showed you when we were in Hong Kong last time. The HCQ arcs thingy.
What HDQ args thingy?
So like the struct that we use for the arguments of the kernel.
Oh, yeah.
Yeah, you need like an arbitrary pointer.
Yeah, you know,
So
okay.
yeah. But I can probably. So what I've been doing with these, because right now we're using the MXFP4 gem from Azure.
Yeah.
I just have an LLM convert their ASM to our style of calling the kernels, and that works.
Yeah,
Yeah,
that might be fine, as long as there's
that's
not
the
too many of
easiest.
them. How much of this is on master? What's the time on master right now?
Time on master is 1.48 as of today. So
And
my time on
where's the gap?
gap is all reduce.
Where's your PR that has the fixes for all reduce?
There is no PR. I can open one.
What do
I
the
have a
fixes
bunch.
look like? Are they mergeable or are they
They're not mergeable. They're soft. I need to fix them and clean them up.
are they fixable in theory?
Well, yes, they are principled fixes. They're mostly like if you have a shrink and then a copy, use a slice or shrink when a slice is
Got it.
gone. Or it's like if you're doing an all reduce, don't make copies. Just directly all reduce into the buffer that you wanna all
Yeah, I
reduce.
mean,
Like a lot of these are just like it's assigning to a temporary and then assigning that temporary back to the buffer where it's like store the
yeah.
thing.
Yeah,
Yeah.
okay. Maybe work on the kernels for now. Maybe this will be easier with the new Rangify stuff.
Yes, I did merge the custom kernel contiguous removal, which that helped. For the other ones, gonna be more of the same thing.
Yeah. Yeah, the custom kernel contiguous change is good. That's universal. That doesn't affect Rangify, right? Because that's changing the input graph. Um, but yeah, so okay, good. Sounds like we just have a bunch of kernels to work on. These kernels are ASM. Yeah, well, that's annoying. There's no hope of trying to express them in our stuff. Source?
I don't think so because you have to go through LLVM.
You mean you have to go through LLVM?
Yeah. I mean, if you express it in our stuff, right?
No, but are these kernels like open source? Like, how does IDER work?
They have a similar DSL to us in Python.
I
For
see.
expressing, it's a little uglier than ours, but it exists
For assembly.
for assembly, and they just like.
Can you link
But
to one of these
but
kernels?
but actually, for these kernels, they don't have like an open source compiler. They just like ship it binary. That's the flash attention blob.
Oh,
That's my impression of some of these like faster kernels.
okay. So there isn't. They're
There's
just
a, like
not
a
open.
principled process, compilation process that just like makes the thing. It's like just the blob of the flash attention kernel for this head size.
I see. So it's like that kind of crap.
Yes, and what I do is just like disassemble and express it.
These CO files are just compiled.
Yes.
Yeah, I mean, how nice if you tell an LLM to take one of these kernels and just like use our ASM syntax and make it as nice as possible, like how nice does it get?
The MXFP4 gem is an example. So this is our MXFP4 gem in master. Kernel class is copied from the AMD as a mammal.
I mean, this
But it's
is
pretty much,
massive. How much of this can we
yeah.
how much if you just tell an LLM to just iterate on it, and this only works on the 350?
Tile sizes, you mean? Yes, tile sizes are kind of hard to put it.
Does it work in our emulator?
Oh, this one I haven't tried on an emulator, but I think it should work. I
Yeah,
mean, like
here's
the emulator code is basically like I just tell codecs if it doesn't work and it fixes it. There's not like fundamental issue with the emulator.
yeah, no, that's good. Yeah, let's get these up and working in the emulator. And let's get them cleaned up as much as possible as we start to migrate the rest of the kernels.
Yeah, I think what I would do is just like get these state of our kernels as clean as possible in our DSL, and then we'll figure out how to express it in higher and higher.
Cool. But yeah, no, I want them all running in our emulator. I want to make sure they all
Yes.
work. Like I want this stuff in CI. We need a very clean kernel library. This seems like a place where we can beat AMD if these IDER things are actually closed source. Like, are they actually?
They are. That's my impression. A lot of these are just like literally
Yeah.
flash attention head size dots s dot bin or dot so or whatever. Not even dot so. Yeah,
Yeah, that's CO.
yeah.
Let me quickly. Is this really?
There's some for loops in here. I mean, like that's the best it can
Yeah.
do. I didn't push it too much, but I think it can like make it nice functions and nice and readable, as readable as ASM can get. I think your step gem was pretty readable at some point.
Yeah, the ASM gem that I wrote for RDNA 3 is pretty readable.
Yeah.
No, it says the kernels are fully open source.
It's a binary that's
I see the binaries committed, but I wonder if they can be compiled. Uh, Bind, host launcher, kernel body. Is it this?
These are hip. This is composable kernel stuff. Like there's a whole other repo that's only assembly.
It's in ITER, it's in the HSA stuff, or
I'll see if I can find it. But these are hip.
okay, no, I mean these do seem closed.
From what I understand, ITER has multiple backends that it can call kernels through.
Mm-hmm.
Yeah.
Like, composable kernel is one backend, and then the hand-tuned ASM stuff is another one. And I believe recently they added kittens as well.
This repo has at least 5 different distinct flash attentions, each with different backends. What GLM is saying.
Mm-hmm.
Okay, cool. So we'll just keep find the fastest kernels, get them in, and then we'll get our assembly backend eventually generating them. Yeah, so that's what it says.
Actually, like one other thing I would mention is that our quantizer is getting better than theirs.
Right? Is it
Yeah,
written
so
in? What's it written in?
oh, it's in hip, but I think what I could do is because every kernel is written in like one backend, I can just easily like fuse stuff.
Um,
Whereas they don't fuse a lot of these things. Like they have a different sweet glue and then they just write to global memory and like
yeah,
default
yeah.
system to global memory.
I mean, the next project for all of this is going to be like, I want to get these kernels in, I want to make them fast, and then we have to figure out how to get our stuff generating these kernels, and we're going to do it from the bottom. We're going to move up layer by layer. All right, so right now we're expressing it in raw assembly, but can we express it in assembly and let it do the register allocation? All right, then can we move up to instruction selection? All right, can we let it do register allocation? Can we let it do linearization? Can we let it do instruction selection? I want to like move back one step at a time through everything until these kernels are expressible in like just full tinygrad. But yeah, that's why it's important we get any kernel we use. I want to make sure it works in the emulator and is tested in CI. But cool. So this sprint seems like it's going to be a kernel migration sprint. All right.
Yep.
Right. Anything else?
That's all.
Okay. Why is GPT OSS not faster?
We are faster.
No, we are
We're in
at
5 hours,
five,
15 minutes now.
we're at 550.
50. It's a 1.65 second step.
1.65 second steps. So you met the target, which is good. Now, where's our next target?
I think before you killed Kimmy, I had Prime Agent running, and it got to 1.3 seconds a step.
Oh, before oh, Kimmy's back, by the way. Sorry about that.
It's okay.
You can also use I posted a
Because I
Kimmy
had
token in
run
employees you
my
can
node.
use with the real Kimmy if you want that. But okay, so you got it to
There's
1
still-
point.
there's still a bunch of there's still a bunch of kernel stuff that needs to happen.
And is this 5 hours 50 on master?
It is just missing some flash attention stuff. or sliding window attention.
Cool. Maybe we get
Then
this
it'll be fully
merged
lit.
and then figure out where you think we can get to next sprint.
Yes.
And then also let's figure out if we're actually on track to meet AMD's target, or if there's any fundamental reason why we just can't.
We should be on track. I asked a couple LLMs if we're like fundamentally off, and none of them said we are fundamentally off.
The LLMs think we can eventually get to the target.
Yeah.
Yeah, 128 minutes. At 350, we got to get to 128. We're almost 3x off. We got to be missing some major things.
I mean, as far as I can tell, and as far as the LLMs can tell, is that there's nothing major actually missing. It is just our gems don't hit grade peak, and then we have a bunch of fusion misses.
Okay. Could we get like a breakdown of like where everything's... well, what do you think we can get to this sprint?
I think we can get to 1.3 this sprint. 1.3.
3. Which will be what total time? It's 12.
440. Hours 40.
This doesn't seem like we're on track. Like, we have to have this done by like September.
Yeah.
I mean, like, do you have a full plan for the target we need to hit? Put together a full plan for the target we need to hit every sprint in order to actually meet this target. Because if we can't meet this target, we're just wasting time. We're not getting paid anything for partial.
Okay.
A full, like, I want to see a full plan for by the end of September. If we don't think we can do this by the end of September, this is just a waste of time. Because yeah, we get nothing for partial.
Yeah, it's just a little unclear to me what certain things will save.
Well, yeah, if you could today just put
until you
together a
actually
plan,
do the changes.
put together a plan that you're confident in that we can actually get to by the end of September, or say, hey, look, I just don't think we can do this. Because yeah, there's no point if we get this down to 3 hours, it just doesn't matter.
Yeah. But yeah, I'll get that by tomorrow, end of tomorrow.
All right, sounds good. Okay, yeah. Send it tomorrow. We'll have a yeah. We need just a full plan to know whether this is gonna be doable or not. Okay. Why is HCQ not deleted yet?
So yeah, I merged it into benchmarks and all these failures in benchmark because of HCQ2, so I'm just debugging these. Yeah. Yeah. So, I also merged like the copy staging, like the copy kernel stuff.
Copy kernel stuff?
Yeah. With HCQ2. So that's actually needed for the CPU to find to to finish the migration to the CPU because CPU doesn't have the copy queue, so it will use like the kernels to copy.
Oh yeah, I see what you're doing. Yeah. I mean, this is kind of like we don't really have to like put that back. What if we just don't run the thing that it's fine for now, but we could also just like not run the thing that creates copies.
What do you mean?
So there is that copy, that like call on copy is being created by is being created by a pass.
Yeah.
Yeah. PM create copy. So what if we just didn't run that pass? Yeah, PM copy from store.
I see.
You know what I mean? Like we could just not run that pass if we don't have an SDMA engine.
Yeah.
Maybe that's a better way to do it. I don't know. This is fine for now. You think we could have HCQ deleted by the end of this sprint?
Yeah. So actually have a PR already to enable it default in CI. So I have several tests failing. I'm just gonna fix it today or tomorrow. And not much of them, so they are all multi-tensor. So maybe, so yeah, I'm just fixing the stability. Also, I fixed the beam problem with HCQ2. So LLMs are still slower than they were before, but because of the CPU in queue time, which also should be fixed with CPU the CPU fully become HCQ2. I mean, basically for CPU right now we still use like the old program stuff. So like all this call like the HCQ1 style.
Yeah.
Yeah, so the idea is just to the same as for AMD, build the binary blob with the function addresses and just execute that in the runners. So that's already possible. I just so yeah, and after that HCQ2, I mean, I don't know how I want to design that, but actually right now the problem why HCQ2 in queue is slower is because we have a lot of C kernels which are sent with Python. And I mean, potentially after we like generated all these C kernels to submit to AMD, we can just kind of run the HCQ2 again on these C kernels, and we're gonna have only one call, like C call.
Yeah, that's cool. Yeah, no, that makes sense. Yeah, you could totally just schedule your kernels to yeah, I like that. I like that like recursive like first you schedule AMD kernels, that gives you a whole bunch of scheduling C kernels, then you run your HQ2 again to schedule all those to basically put them in a graph. And then yeah, you're left with one C call. That's great.
Yeah.
Cool.
Yeah, also I don't I think I'm gonna break like the HCQ1 CPU stuff for now. I don't know if someone using offloading, that's gonna be slow.
Using offloading.
Yeah.
Oh, yeah, that's fine. No, well, if you just mean like optimizer offloading, that doesn't matter. As long as it doesn't make like common USB stuff slow.
Yeah.
Yeah, no, that's totally fine. Yeah, we could delete that. But yeah, it would be great if we could delete HCQ by the end of this sprint, be back down below 25,000 lines. Yeah, then I think
No.
and I will look into that network card for you. I plugged the wires in, but the wires they say Mellanox on them. Usually this doesn't matter, but I don't know, maybe Broadcom needs different wires. So I'll buy new wires. But they're just plugged into the switch.
Yeah, I know I haven't looked much into that. Like I'm just managing GPT, and it actually not really happy with the card on R5.
Not happy
Some
with the
reasons, yeah, I mean for some reason, like the card reports that like the ROC E capability is off on it.
Oh.
And actually the driver also doesn't enable like the
I can
I
deal
don't know,
with
maybe
this.
that's because of the
Yeah. This
maybe
is
because of
my
the
job.
cable.
I will get the machines pinging each other. This is my job. Yeah, you shouldn't have to worry about this. Yeah, let's just get HCQ deleted this sprint, and then next sprint focus on multi-machine training and potentially that like multi-compute queue stuff. Did you follow that at all? What it is in AMD hardware?
Yeah, multi-compute actually it's like already should work with HCQ2. Yeah.
Yeah, it shouldn't be.
I
It
think
shouldn't be a big deviation. I mean, basically, we just need to have two queues, some primitive to synchronize between them. I've been working on. Open source mech replacement. Do you know if there's a way? Like, do we actually need two queues? Is there a way to like launch a kernel and then not synchronize that kernel and launch another kernel right after it?
yeah.
You know what I mean? So it could actually be one queue.
Yeah, but actually I don't know. Yeah, it's possible to do that, but there is like kind of the barrier. Like you should place between two executions to just make them dependent, like make them to wait for each other. I mean, yeah, there is like barrier only. Like you
Yeah,
cannot wait for like execute like for the first or the second. You can just put barrier and wait for both.
yeah. That makes sense. I mean, like where I see us going, I think finally, like by the end of this year, Tinygrad's going to be caught up with like the rest of the world. We're going to have basically state of the art kernels matching like the current like Tialang Torch paradigm. Um, I think most of next year is going to be focused on mega kernels, and then like kind of what mega kernels are. So yeah, like this idea, and this is why HCQ2 is so important. This idea that like, what really does it mean to have two kernels? Well, the kernel aspect means several things, right? There's a call aspect to it, but there's also a barrier aspect to it, and these things are completely different.
Yeah.
Like a lot of I think where we're really going to start to see gains over everybody else is when we start to pry apart these concepts that are considered uh like once we can go below the API layer. Right now, if I'm in HIP and I have a single queue and I launch a kernel and then I launch a second kernel, HIP is going to promise me that that first kernel entirely completes before it launches the second kernel, right?
Yeah. Yeah. I mean, you
There's
can
no
use
reason.
streams or
Well, I could use two queues and I could put the kernels on two queues. What do you mean by streams?
that's actually the same thing.
Oh,
In
streams are just
heap.
okay.
Yeah.
But yeah, I mean the distinction there is yeah, you're not doing it's a lot easier to think about things when they're just all like single threaded and you don't have to deal with synchronization. Like the synchronization is just kind of implicit.
Yeah.
Because like I want to have you looked into like how other people are doing mega kernels?
Not much, but yeah.
I mean, eventually, I think what we're doing next year mostly is going to be something kind of like writing an operating system. And I want this operating system to be universal. I want this operating system to work on GPUs and CPUs and like support the kind of primitives we need. Imagine instead of having all of using all the GPU's dispatch logic, we just have 256 long running kernels. And these kernels like parse the queue themselves.
Yeah.
Um,
So yeah,
but it's very
basically, I think all the
oh, good.
I mean, like the op CPU is kind of the same thing, and I think the only primitives we might be missing is like the atomic operations. And I think like the CPU is really close to the mega kernel. I mean, in some way.
I'm not exactly sure how the CPU one works, but what I think the CPU one is you're taking a global dimension and making it threads, and then you're putting a loop in each one of those threads. And you don't exactly want to do this because the different CUs or the different threads may run different numbers of pieces of compute. See what I mean by that?
Yeah, yeah,
Does the CPU one support that now?
yeah. It won't support that.
It won't support that. Yeah. I mean, that's it's just look, it's not for right now, but it's what we kind of have to think about, right? Like we don't want to pre-decide where every piece of compute is going to be run because you don't know, you can't calculate how the cache hits are going to go and stuff. Um, we want the like GPU itself to and this is all going to depend on like what the latency is of atomics or how well we can synchronize these things. But I suspect that we can build runtimes that can effectively run the same queue. Again, this is why it's so important that we move to HCQ2 where we can like look at what these queues are. We can run the same queue in a way that we can do much more like fine grain overlapping.
Yeah,
But yeah, no, I mean, a lot of this, I think a lot of the projects next year are going to look like, uh, yeah, how can we best synchronize between CUs? Because I remember the experiments with the synchronizing between the XCDs and atomics were a lot slower than whatever the mech was doing.
yeah, yeah.
Yeah, like why we needed all that AQL stuff. But the open source mech, we're going to finally get to see what the mech is doing.
All right.
Yeah, I'm excited to understand that. But cool. Great. HCQ gone this sprint.
Yeah. Yeah.
Right.
So also, I forgot to mention, but then CQ2 now has a proper profiling. So in Wiz equals to.
With viz equals
Yeah.
2, so the SQTT stuff works.
Not SQTT, but I mean SQTT is kind of easy to port, but I mean all the timings now fixed and works fine.
Right. That's that. HCQ2 equals 1. Is equals 1. Python test tiny test gem. Does HCQ2 take longer to start up? Oh, I did viz equals 2. Oh no, that's going to break my computer.
So CQ, I mean, yeah, it takes like, what do you mean longer to start up? I mean, like the schedule passes take, I think, like 50% longer on average.
Occupied. Why is that occupied? Use port to change. Oh. Yeah, I feel like every once in a while it's just like really slow. What's it doing? that was fast. Okay, cool. Oh, nice. Yeah. I see all the HCQ compile kernel stuff. That. Nice. So that's what you mean by it works on the on
Yeah.
the profile? Yeah, that's great.
Yeah.
Sweet. Yeah. The more we can reuse the same abstractions, the better. I really like the double HCQ thing. Cool. Anything else?
No.
All right. On to mine. Why is Rangeify still long and confusing? So I didn't get to work on it too much last sprint. I worked on all the stuff needed for fast Quen 3.6. I did that custom kernel contiguous thing. I did the prototype of it. Yeah, so we have state of the art Quen 3.6 on AMD. It's not quite merged yet, but it should be merged this sprint. Been slowly chipping away at all the little pieces of it. It uses a bunch of custom kernels, but I think that again, like this idea of we have these custom kernels and we work to remove the custom kernels to make our code gen good enough to generate them. Seems like the right sort of idea. The main thing, so the flash attention custom kernel, there's a Kimi delta attention or whatever data delta net custom kernel because we don't have scan. The flash attention because we don't have pcontig. There's Kimi delta attention because we don't have scan. And then there's a bunch of linear kernels because we don't have it's not finding WAME. The decode kernels Beam finds really fast for the GGov packed stuff, but the prefill kernels it doesn't because it doesn't use the WAME for some reason. So that's probably fixable with the uncharred stuff. Yeah, but it's basically just those three things that prevent Tinygrad from beating the state of the art. And it's 3090 state of the art too. It's not far off from being state of the art on 3.6. It's those three things. So yeah, this sprint I'm going to work mostly on Rangeify fixes. There's a bunch of like hacks to deal with like the custom kernel thing. Right? So it's better that we don't put the contiguouses in the user graph, but now the contiguouses are being added by this realization pass, which happens pretty early. We shouldn't have to do that. To have a pass later on in Rangeify, like we have to stop saying that there's going to be one magical place where we decide where all the buffers are going to be. So the new Rangeify is going to basically insert too many buffers, insert buffers in like almost every place you could want a buffer, and then figure out which ones it can remove, and then figure out which ones are required to add because of things like custom kernels. We can do all of that really late. So if anything like cancels out, like right now, we still maybe are even thinking about the fact that sometime you have to reshape for a custom kernel, and movement ops should be so far gone by this point. We have one pass very early on to remove all the movement ops, and then once we're in the Rangeify world, we can do a lot of kernel optimizations directly on that stuff without ever having to think about a movement op. So, yeah, that's good. That I got Kimi running. Well, Codex got Kimi running. So we're getting 8 tokens per second Kimi in Tinygrad. So just like if we could get like 10x more, that would be kind of nice. But that was with just Tinygrad's kernels, not with kernels. But I think that to really get these high performance, this is a place where I think Tinygrad can be competitive. If you saw these like ultra high interactivity things, ILRT. Because I think that's a place where we can be competitive and a place where some people would be really interested in getting. I don't know. I think about like what an advantage I would have had. I went to DEF CON this weekend, and I would have had such an advantage in the CTF if I had 500 token per second Kimmy when everyone else was using. Well, most people don't even know how great Kimmy is. Most people were struggling to get codecs to not throw security stuff. Kimmy doesn't do that, but yeah, 500 token per second Kimmy gives you a real advantage in a lot of competitive environments. So I think that this is going to be the thing next year. If we really are at a place where LLMs are like kind of good enough, which they like kind of are, they can always be smarter, but there's two axes to this. There's smarter and then there's faster. Fundamentally, and everyone's moving towards this way of thinking. It's not a question of how smart your LLM is. It's a question of how often it completes the task and how quickly it completes the task. That's all that matters. So we're not going to build smarter LLMs, but we can build quicker LLMs. So I think that's a good thing to focus on. Cool. How close are we to merging RDNA3 assembly?
Yeah, I spent the last week just getting the last bit of tests passing. We're down to 6 tests for the entire CI suite.
Right.
I simplified it a lot. We're under 600 lines of code for the entire backend file, which I'm pretty happy about. Now is basically just trying to make it not generate slop. So even if you look at some of the gem kernels versus LLVM, there's a lot of unnecessary ALU ops. I found a problem where in the linearizer, it wasn't assigning the proper priority to loads and stores because they're already ops.ints. So it wasn't batching memory ops together or placing them like early and late. So just today, I've started working on making the code actually good and starting to look at performance. I got like increased gem performance by like 10% just this morning. There's a lot of room for improvement there. One problem I'm having is I don't understand why the CI tests are taking so long compared to the LLVM backend. Like every time I push to my PR branch, it's like 15 minutes and then it just cancels. And locally, it's like a 10% difference in time versus LLVM. I don't think this is inherent to ISA backends because x86 is pretty close to the other compilers. Here, I can post that.
I see your test being slow. I mean, yeah, it's
Like
probably
if
just slow.
I run it locally and it's like 60 versus 70 seconds. And then here it's 3 times as long. Is it something about the runner environment?
When you run it locally, are you running with cache level 0 or are you running with a cache?
I don't specify.
Oh, well, that's what it is.
Yeah.
Oh, okay.
Yeah. So you're having to compile all the instructions with the compiler. Run with cache level 0 because that's effectively what you're getting in CI.
Okay.
Because if
So
all
it's
your
just that
things
much
are already,
slower.
it's got to compile everything, right?
Yeah.
Yeah, but you can
So that's kind of annoying.
run one test with Viz, and you can look at what it's doing, and then run it with cache level 0, and you'll see how much slower it is. But yeah, that's probably what that is. I also see a ton of changes to a ton of different files here. Are there any small things to merge first?
I don't think so. Most of them are specific to this backend, I think. There's like, I'm pretty sure, like they're very small changes.
No, I mean, look, I look at your change to LVMIR, right? Like you have this.
I moved the WAMA things to opt, right? Just so I didn't have to duplicate it in my backend.
Yeah. But like that's the kind of
Yeah.
thing that can get merged as its own PR.
Okay.
If it's a simplification. I also see little things like group where you're adding the KW args, right? Like that stuff can be merged. To storage scalar. I don't know how I feel about invalid type returning X and not throwing an exception.
Yeah, that was a bit of a hack. Sorry.
I mean, why does you even need that, right? Shouldn't it just return X already?
No, that was causing a problem. I probably could have found a better way to fix that. I don't know. Maybe it was something wrong in the backend. That was for B float stuff.
I see. And then I see huge diffs to these ins files too.
Because I had to regenerate it. So I had to declare a class so that the arg, if I use it as an arg, it has to be hashable or compare against itself. So I create a class to wrap the instructions in, so that it doesn't throw an error.
Create a class
So
to wrap.
all of them. If you go to DSL, it's in SOP. It just wraps the like.
I see what it's doing. I don't
Yeah.
exactly understand why you need that.
Otherwise, I get an error that can't compare the arguments when it tuplizes them, I think.
Yeah, I wouldn't fix it like that.
Okay.
Yeah, no,
It throws an error because they're like functool partials, and it doesn't like that.
yeah, I get that. This should be thought about in a different way, right? Because like the fundamental problem you want to solve here is not why can't I compare tuples? It's why am I comparing instructions?
Okay. But
Right, this
if
is
we
related
pass them as args,
That's not the problem. This is related to your load ordering issue too.
okay.
You know what I mean?
No.
So do you know where that compare is happening?
No.
That compare
Is
is
that in
happening in the
linearized?
linearized. Yes.
Okay.
So the linearizer
Okay, so
where
it's-
yeah.
yeah.
So the right solution here is not to add some class so you can compare them. It's to say, what do I actually want the sort order to be?
Okay, yeah. So why am I comparing them in linearized? Yeah.
Yeah. Yeah.
Okay.
Or so also the linearized the comparison is it will short circuit if it'll compare differently with something earlier in the tuple.
Yeah. Yeah.
So maybe
So
you
I
just want
could add something to I could just check if it's a functool partial or like an instruction, and then it will just fail then or compare then. Yeah.
yeah, you could potentially do that. But yeah, I mean, think about what you want because that sort order is not obvious.
Yeah.
And the
Okay.
solution is not to hack something to make it pass. The solution is to think
Yeah.
about what you want the sort order. Cool.
Yeah. So what are your thoughts on like a good benchmark for when it's mergeable performance wise? Like if I'm looking at gem and tensor cores.
I would run whole models, and once your whole models are within like 30% of LVM, you're good.
Okay.
Maybe
Okay.
even within 2x. It shouldn't be more than 2x. If it's more than 2x, you're doing something pretty wrong. Like the things that I don't care about are things that are like, oh, well, I can, like LVM has like heuristics to deal with cycles and, oh, okay, this instruction takes this many cycles and reordering, blah, 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 blah. Micro optimizations like that I don't care about. But if you're off by more than 2x, it's probably because you're not doing memory correctly. I want it doing memory correctly because that's pretty fundamental how the thing works.
Okay.
2x for like MNIST trainer, but not just MNIST trainer, right? Like 2x for MNIST trainer, ResNet, Llama, everything within
Okay.
2x. Yeah, you can be 2x long.
Sounds good.
Yeah, no, I think it's worth 2x is a good number for that, and it's worth getting this merged, and then we can figure out what optimizations we're not doing.
Yeah.
Great. Okay. Yeah, I think that's pretty much the meeting. Yeah, you can see where this is all going. It all takes a long time, and I probably say this a lot in a lot of meetings. But where we're eventually going to go with this is we have these very fast ITER kernels, and we can slowly back them out. So, like, can we run the register allocator? We rewrite the ITER kernels to not have any register numbers, and then run the register allocator on them. Can we then put them in a graph and not in a linear? Then can the linearizer recover that structure? Then can we not do instruction selection, right? Can we back out instruction selection and go to tinygrad ops, right? Then can we go to higher level tinygrad ops? Can we remove the WAMAs and stuff and have the WAMA thing automatically find them? All that instruction selection stuff should be good. And okay, now we're starting to get to Rangeify, right? Can we back out beyond Rangeify? Can we write this just in terms of something that looks like AMD copy map all? And then we go up even higher and say, okay, can we just write this in terms of tensor, A, B, and that just generates a fast gem that matches either. So we can do this slowly, one step at a time. It's very important that we do things methodically and that we have CI working well and that we have testing working well, because that's our advantage over everybody else. You see all these people, like, look at that tile RT thing. It's cool, smart people doing it, but start to look into how those microkernels are actually working. And yeah, it's very, very specific to NVIDIA and to, let me find the file I was looking at. Like, you see how they have directories for each model, and then for each model they have here's your like temp vars. Right? Like, there shouldn't be something called temp vars. That should be automatically scheduled. But yeah, this is actually cool to read. This is actually kind of better than I thought. This is pretty good. They're tiling people are ahead of us. We need to. We're nipping on the heels of the tiling people. I don't even actually totally understand this. Oh, interesting. They're like registering like these like micro ops. But yeah, fun thing to read. But no, this is like not where we want to go. We don't have to think about micro ops. We want to think about basically how our entire compiler can target both mech and our runtime and Tensor's runtime and CPUs and everything. So I think that's where this eventually goes. Cool. That's the meeting. Thanks, everyone.